Hey everyone, it's Mr. Mott. What I want to do today is go over how we write chemical equations involving elements and specifically the diatomic elements. Most of our elements on our periodic table exist as atoms and they exist by themselves. But certain elements always exist in pairs, and that's where this term diatomic comes from, di meaning two. The diatomic elements are hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And these are all diatomic. And the reason I wrote them in this order is because we can remember them with a sort of by putting them all in one word, a kind of a made up word, Hofbrinkel. So all of our diatomic elements, you can remember them as being Hofbrinkel elements. So what that means is that if we're talking about hydrogen as an element, it's going to be given the formula H2. Oxygen as an element, O2. Fluorine as an element, F2, and so on. All of these, when we see them written as or described as being just the element themselves, there are going to be two of them. All right. Let's look at a couple examples here. Hopefully, illustrate this idea. Our first example, aluminum metal reacts with chlorine gas to produce aluminum chloride. So we're going to first start out by writing our symbols here. Aluminum symbol is Al. And when it's a metal, we're going to give it the state of matter of a solid. It's going to react with chlorine gas. Chlorine is Cl. And then we give it our symbol G. All right. And before we move to the product side, because both of these are elements, we want to check our list of diatomic elements. Aluminum is not on there, but chlorine is. So chlorine is a diatomic element, so there's always two of them. All right. Now, when these two elements combine, we're going to make aluminum chloride, which is an ionic chemical. So what we need to do is we look on an ion chart to be able to determine what the charges are as ions. And aluminum is a 3 plus charge, and chlorine is a 1 minus charge. Now, from the ions, we should be able then to balance our charges out by having 3 chloride ions to balance out the positive 3 to make a neutral compound. So our formula for aluminum chloride would be AlCl3. One thing I forgot to state would be the state of matter, so I guess I'll just leave it blank. But that's the main idea. All right. Now something just to go back to, why is this Cl2 and why is this Cl3? Well, the Cl2 is because this is a diatomic element. The Cl3 is based upon how it's interacting with the other ion. And because aluminum is a 3 plus charge, we need 3 chloride ions to balance out the charge. All right. For this video, I'm not going to worry about balancing the equations, just sort of identifying from the word equations to the symbols. That's the main purpose. All right. Let's take a look at our next example here. Copper solid reacts with oxygen gas to produce copper 2 oxide. So copper symbol is Cu. We'll give it the symbol S. Reacts with means we'll use the plus sign. Oxygen gas would be O and then the G. And then we're going to produce copper 2 oxide. Before we move to the product side again, we're going to look at, are either of these one of our diatomic elements? Copper is not on our list anywhere, but oxygen is. So oxygen is going to be given our symbol O2 because it's one of our diatomic elements. All right. When we look at on the product side, trying to figure out the formula for our copper 2 oxide, the 2 is telling us the charge on copper because copper can form two different charges. So copper is going to be copper 2 plus. And when we look on an ion chart for the oxide, it's going to be O2 minus. So because it's 2 plus and 2 minus, we just need one of each in our compound. So our formula is going to be CuO. And once again, I forgot to write down what state of matter it was, so we'll just leave it blank. All right. So again, looking at the formula of our element, this is O2 because it's a diatomic element. We only have one oxygen here because when we look at the ionic charges to make a neutral compound, we just needed one O2 minus for every copper 2 plus. All right. Last one we'll look at here, a little bit different. We had magnesium metal. So we're going to write our symbol for Mg is for magnesium. A metal for a state of matter would be S. It's reacting with, so reacts with is going to be a plus sign. Most of the time in honors chem, we don't require you to know the acid, so I provided you formula there for hydrochloric acid being HCl. Since it's an acid, I'll give it that aqueous symbol. To produce, I'm going to use an arrow sign. And then for magnesium chloride, we're going to have to look at another ion chart again for these two. Magnesium being a metal, chlorine being a nonmetal. So the magnesium ion is Mg2 plus, chloride is Cl minus. So we would need two Cl minuses to balance out the magnesium. So my formula would be MgCl2. I forgot our state of matter again. That's okay. And then lastly, we have hydrogen gas. Now, again, we have our elements here, which is magnesium. Is it one of our diatomic elements if we refer to our list from up top? And magnesium is not anywhere on our list, so we're just going to leave it as Mg. However, hydrogen is one of our diatomic elements, H2. So I'm going to give it that abbreviation or the subscript 2 there because it's diatomic as an element. All right. Hopefully that's helped be able to translate some word equations into symbols that involve our elements. Thanks for watching.